Okay, so today we're going to start looking at recursive formulas, and I'm not sure if you have done these before. They are technically in the Math 1 curriculum. However, I sometimes skip them whenever I teach Math 1 because they don't put them on the test very often. So you may or may not have seen this before. So a sequence is an ordered list of numbers that form some pattern. That you've definitely seen before because that's like whenever you had 1, 3, 5, 7, ... right? You've been doing that since you were a small child. A recursive formula is a formula that defines each term of a sequence using the preceding term. So, more or less, it's the rule, how do you get from one term to the next, right? So, like in my pattern here, what's the rule? How do I get from one term to the next term? Just add 2 to the previous term, right? So, it's going to be a way of expressing that in symbols. An explicit formula is a formula we can use to find the nth term of a sequence. That's what we're used to doing in math. Like whenever I give you a function f of x equals 3x plus 5, that's an explicit formula. Because if you want to know when x equals 7, what the y value is, you just plug in 7, right? You just plug the number in. You don't have to know the numbers before. So, the first thing we're going to look at is I'm going to give you this explicit formula. F of x equals 10 times 2 to the x power. So let's fill in an explicit formula, like I said, is what we're used to dealing with, right? So we'll be dealing with some exponentials and linears today is what we're going to look at for our recursive formula. So I've got 10 times 2 to the x power. If I plug in 0, that's 10 times 2 to the 0 power. What is 2 to the 0? 1. So this is really 10 times 1, so I get 10 there. If I plug in 1, 10 times 2 to the first power, that's going to give me 20. If I do 10 times 2 to the second power, 40. You guys starting to see a pattern of what's happening here? What's the next one going to be? 80, 160, 320. So when we write a recursive formula, we are not thinking, if I plug in 4, what does it give me? 160 is the answer, right? We're not thinking about what we get if we plug in the number. Explicit formulas are more useful a lot of times because we can just plug the number in. There are going to be some things when we get to the more advanced ones here we have to use recursive formulas for because explicit don't work. So, recursive formulas say, how do I get from one term to the next term? Right? So what is the pattern with my y values here? Times 2. That's what's happening each time, right? So, recursive formulas, typically we are not going to use x's and f of x's. In fact, hardly ever do you see them written like that. So, what we use instead, the x is usually an n, so it's the n is like your number of your term, first term, second term, third term, nth term. And then we usually call this f of x our a sub n. So using these variables, we could say, instead of f of x here in our explicit formula, we could say a sub n equals 10 times 2 to the n power. Right, so this would also be an explicit formula using the n value here. So, with a recursive formula, we're going to have a couple variables that are typically going to be used. There can be different things that happen, but we're going to mostly stick to the standard notation that we see. So, a sub n is going to be my nth term. And the other variable you're going to see used here is a sub n minus 1. And n here is just a number. So if I have a sub 5, it means the 5th term. If I have a sub 4, it means the 4th term. So a sub n minus 1 is whatever nth term I have minus 1, which means it's the term that comes before n, right? It's 1 less than n. So it's the term before a sub n. So the notation really throws kids off, but the idea is pretty simple. So like once you get this notation, I was dealing with this in second period with the function notation. They were really getting confused because like if I asked them for f of 3, they didn't know what to do, even though you're really just plugging in 3. That's what you're doing. Same thing happens here. You like hit the panic button because this notation looks weird and crazy. But the ideas behind this are pretty simple. So usually once students get the notation down, it's not difficult for them. So don't panic just because this notation looks so weird. So whenever we set up a recursive formula, a sub n equals is how we are going to start pretty much all of these. It can be done in different ways, but I'm going to just stick to like the most basic, most common way that this is done. So, if I want to know a term, if I want to know the third term, then to find it, I take the term before it and I multiply it by 2, right? So if I want to know what comes next, like for example, if I want to know the next term here, if I want to know the 6th term, I would take the term before it and I would multiply it by 2 and I'd get 640. Right? If I want to know the next one, I take the term before, 640, and multiply it by 2. Right? So, our formula here is going to be 2 times a sub n minus 1. All this is telling us is to get a number on the table, multiply the previous term, that we could also think of this a sub n minus 1, we could also just call this previous term here. Multiply that previous term by 2. So this would be our recursive formula. Sometimes they will also include like telling you a sub 0 equals 10, or sometimes they do a sub 1 equals 20, telling you like one value that you need to start from there. Now, this particular type of sequence is called a geometric sequence. It is a sequence in which each term is found by multiplying the previous term by a fixed number called the common ratio. So in this particular case, our common ratio would be 2. It's the number you're multiplying by each time. Okay, questions? All right, let's look at a linear equation now, okay? So this time I went ahead and used this a sub n notation, right? So we've got a sub n equals 2n plus 5. That's our explicit formula. So if I want to know the 0 term, if I want to know what a sub 0 is, I just plug in 0 for my n. So 2 times 0 plus 5 is just going to be 5. If I do 2 times 1 plus 5, 2 times 1 plus 5, it's going to be 7. If I do 2 times 2 plus 5, 2 times 2 is 4, plus 5 is going to give me 9. What's the pattern here? What's happening each time? We're adding 2. So we'd have 11, 13, 15. So if I want to write a recursive formula for this situation, I'm going to say a sub n equals, and then I'm taking a sub n minus 1, which just means the previous term, what came before it, right? And what am I doing to a sub n minus 1 each time? I'm adding 2. So it's a sub n minus 1 plus 2. You might see that they also put down here below it a sub 0 equals 5. Sometimes that's included. Sometimes they just give you the formula. It just depends on what they're asking for on a problem. Okay. This type of sequence is called an arithmetic. It looks like arithmetic, but anytime I've heard it said by other math teachers, they usually say arithmetic sequence. It is a sequence in which each term is found by adding a fixed number called the common difference. So for this particular problem, our common difference is 2. We're adding 2 each time. Okay. Today we are only going to look at geometric and arithmetic sequences. Not all sequences follow these patterns, right? Because maybe your rule is that you're going to add or multiply by 5 and then add 2 each time. Right, so that's going to be a more complicated situation that we'll look at in our notes tomorrow. But today, everything's going to be either you're just adding a number or you're multiplying a number. Okay, sometimes they might be negative. All right, so one thing that you're going to be asked to do is write a recursive and explicit formula for tables that you are given. So again, like if I have the first term is a sub 1, second term a sub 2, nth term, a sub n. The term before the nth term, a sub n minus 1. So if I look at this table, if I want to write a recursive formula, for recursive, I'm going to do that first. I'm only looking at my a sub n's and thinking, what has to happen for me to go from one number to the next? So what is happening here? What am I doing? Just adding 10 each time, right? Okay, so my recursive formula is going to be a sub n equals a sub n minus 1 plus 10. That tells me to get a term, I take the term before it and add 10. I'm also going to put a sub 0 equals negative 3 here. Whenever you're dealing with these types of problems, I actually almost feel like the recursive is easier to write than the explicit. So the explicit formula, what we're looking for here is a sub n equals, and then we need some formula right here that involves the n. Not an a sub n minus 1. So, like, I need to be able to take 3, plug it in, and figure out what I would get here. So, what could I say for this? Anybody know? Okay, I'm hearing 10 n minus 3. All right, so, we're going to stop here in just a second. So, I've got 10n minus 3. And this is going to work because if I plug in 0, I get negative 3. If I plug in 1, that's 10 times 1 minus 3, which gives me 7. If I plug in 2, 10 times 2 is 20, minus 3 is 17, right? So, a trick here. If this is arithmetic, right, if you are adding something each time, then this number right here is always your slope over here. And this number right here is your y-intercept over here. So, let's see. I know I said I was going to stop, but we are going to do just one more problem. Just so you've seen enough to be able to do what I need you to do tonight. So one more, and then we're stopping, I promise. Alright, so for this problem, we're supposed to write a recursive and explicit formulas. So what's happening each time? I'm dividing by 4. But I said it's always multiplying. So what's the same as dividing by 4? Times 1/4. So instead of saying divided by 4, let's say it's times 1/4. You always want to do multiplying. Same thing's true if you're adding. Like subtracting is really just like adding a negative number, right? So I'm going to say a sub n equals 1/4 times a sub n minus 1. This is my recursive. And then I need to know a sub 0 a lot of times. Is a sub 0 on this chart? It's not, right? Because it should be over here where like n equals 0. It would be right here, but it's not on there. But what would it be? It would be 400, right? Because if we're going backwards, we'd multiply by 4. 400 divided by 4 is going to give us 100 here, so it would be 400. So the a sub 0 is 400. I'm wanting a sub 0 specifically because it's going to help me write my explicit. Okay, because of time, I'm not going to have you guess on this. If I want the explicit, whenever you have something that's multiplying by something each time, it's going to be an exponential function. So your a sub 0 is your initial value, right? So this is going to be 400 times 1/4 to the x power. And if we tested that out, if we try, like if I want to know the fourth term, if I do 400 times 1/4 to the 4th power, you can see I get that number I'm supposed to get. Alright, so in this case, your a sub 0 ends up being your a value for your exponential. It's your a value. And then the common ratio here, that's your b value for your exponential. So you're going to have an assignment on Delta Math for this. I might shorten it up a little bit because we didn't go through notes so you won't have quite as many to do on that. But it will have you doing these things. It will only be these two types right now. Alright, so instead of me giving a warm-up, the best thing for you to do for a warm-up, if you have not, or even if you have already done some, is to look at that Delta Math assignment that I gave you guys yesterday but was not required. That optional Delta Math assignment. So while I'm going around to check your homework really quickly, if you guys will log into Delta Math and look at that assignment, it's probably it might be down in the section where it says it's late now, but it wasn't ever really one you had to do anyway, so it's not a big deal.